Okay, so what I would like you to do is to copy down these four functions, f of x, g of x, h of x, r of x, and then think about these four different functions. By the way, they are in standard form, ax squared plus bx plus c, but I purposely put the c value, the constant, as 0 on all of these, all right? But either way, all of them are quadratic functions. They're all parabolas. And what I would like you to do is think about those parabolas and see which parabola would best model the given situation. And the first situation that we're looking at is the path of a football pass for a touchdown. Okay, so I'm gonna pause it, give you guys a couple of minutes to copy down those four functions, and then I want to give you a couple more minutes for you to talk to a partner and find out which model, which function, h of x, g of x, r of x, or f of x, which one would give you the best model for the path of a football pass for a touchdown. Let's begin with this, guys. What does the path of a football during a game look like? Like this, right? Let me get this out of the way. Something like that, right? So your quarterback wants to throw the ball to this player. He's going to be running in that direction. So it does travel in the path of a parabola, okay? Now, the parabola does reach a maximum height, and of course, is this parabola opening up or down? Down. It's opening down. So what does that tell you? We already know about transformations. We already know about parabolas. Which of these four functions right here, does this one open down? Does this one open down? This one? Which of the four opens down? The top and the bottom one, the f of x and the r of x. Both of them have the a value being negative. So both of those open down. Now the question is, which one of these a values will produce a wide parabola like this? The 1 over 24. So r of x would be the only one that could possibly model a pass in football. Okay. So do me a favor, on your notebook, write down the answer r of x. Now you should write down the path of the football would be r of x. And you could write down that function again if you want. Again, we were able to determine which one models it best just by analyzing the a value of our standard form quadratic function. So the next situation would be the path of a swimmer underwater as she dives into the pool at the start of a race. Okay, so we're not really talking about how she jumps into the pool, but actually once she hits the water, she's going to travel in the form of a parabola, right? Let me help you out here, give you a visual. Here's two swimmers. And as you could see, we have them jumping right in here. And she's going down. She probably reaches her deepest level right here. And then she has to pop back up and start swimming up here on the surface, right? Okay, so this is a parabola that's opening up, correct? Let me just sketch this like that. Okay, and this is probably like the vertex. If we want to think about the parabola, that's her lowest value. But anyway, which one of these opens up? H of x and g of x. The question is, which one would best model this parabola? G of x. Definitely a wide parabola. If the a value is closer to 0, it's definitely wider. This would not be good unless like somebody gets dropped off a building and then dives right into the water, right? So yeah, it would have to be the wide parabola opening up. So this one would be g of x. So I hope you guys could write down this question, the path of a swimmer underwater. She dives into the pool at the start of a race, and you could actually jot down that g of x function that we said. It opens up and it's wide. Opens up and it's wide. Okay, so let's move on to the next real world situation. Here we go. Path of a pop fly in baseball. I want to hit pause, talk to a partner, go for it. Ladies and gentlemen, in order for us to really understand, well, you need to know what a pop fly is, first of all, right? So here's a visual for us. The batter hits the ball, and for a home run, you want your parabola to be pretty wide so it could actually go over the fence, right? But a pop fly is more like he hits a ball, it goes up, and then it comes back down, and somebody usually catches it, right? Most of the time. So pop fly like it's pretty narrow. The parabola is pretty narrow. It's opening down. So knowing that, which one of these guys is narrow opening down? Well, it's the f of x function. So that first one. Good job. Okay. So the path of a pop fly would be modeled best by that f of x function. Okay. Let's move on to the last one here. Which one of the following functions would best model number 4 right here, the path you will take when bungee jumping off a bridge? Go ahead and copy that down, number 4, the path you would take when bungee jumping off a bridge, and then figure out which one would be the best function that models that path. So what do you guys say? H of x, absolutely. Let's first think about that situation, bungee jumping, right, off a bridge. So this guy right here jumps off this bridge, and he's going to bounce at some point way down here, right? So if you were to draw the path, he's going to bounce somewhere way down here and then pop back up. Probably not too far, then he'd hit himself right there, right? No, let's not do that. Anyway, so that path is going to be a pretty narrow parabola that's opening up, and the only one that's opening up is g of x or h of x. This one's wide, this one's the only one that's narrow. So h of x would be the only possible option for bungee jumping. Okay, everybody cool with this? All right, let's go back to that swimmer situation. So the swimmer situation, it was number 2, the path of the swimmer underwater. What I would like to ask you right now is the path of this parabola, she reaches her minimum point, then she has to pop back up. What I would like to know is how deep is she at her lowest level? Okay, down here, how deep is she? Is that 2 feet, 3 feet, 4 feet? Now, in order for us to answer that, what am I really asking you for algebraically? The vertex, right? The vertex of which function? Which one was this one?
G of x.
G of x. So go ahead and right now find the vertex of g of x. Find the vertex of g of x. So let me get this out of the way. I want to pause it. Let's see which awesome student could tell me how deep this person is in the water at her lowest point of her dive. Go for it. So we already know that the dive parabola that we're using to model it is g of x. It opens up, it's wide, it's 1/14 x squared minus 1x. Now, in order for us to find that minimum value, that deepest part of her dive, we're really asking for the vertex. And we all should know that the vertex is x equals negative b over 2 times a. So negative parenthesis over 2 times parentheses is what I recommend you do every time you use the formula. Label your b value, which is negative 1, your a value, which is 1 over 14. So the b value of negative 1 goes right in there. The 1 over 14 goes right in there. Now, technically, you could type this in exactly the way it is into the Casio, and it should give you the answer of 7, right? But I'm going to work through it so you could learn how to do it without the calculator. So the minus minus changes to plus plus. We end up with a nice, beautiful 1 up there. And the 2, you could put it over 1 and multiply the top with the top. So 2 times 1 is 2, and then 1 times 14 is 14. Now, 2 over 14, that's a fraction that could be reduced. It becomes 1 over 7. So what we really have is 1 divided by 1 over 7. And that looks really funky. So it'd be better if you write it horizontally. Instead of saying 1 over 7, you could rewrite it like this, where you have 1 divided by 1 over 7. Now, why would I do that? Because when you divide by a fraction, you really change it to multiplication, and you flip the fraction that you're dividing by. Okay, this is all from Algebra 1. I hope you guys remember. And if not, you could all type it into the calculator and it'll do it for you. But anyways, we have 1 times 7 over 1. That's just 1 times 7, which is really 7. So what did we just find right here? The vertex x value, right? The vertex x value. Yeah. All right, so the x value is 7. So here I go. Vertex, the x value is 7. I still need the y value. And the y value is what really tells me the up and down, how deep this diver actually goes. All right, so I need to find out that y value by plugging in the x value. So let me get some space here. I'm going to rewrite my function exactly the way it is, but instead of x's, I'm going to put parentheses. So I have 1 over 14 parentheses squared minus 1 times parentheses. And we're plugging in that 7 right in there. 7 squared is 49, so you really have 1/14 times 49 minus 1 times 7, which is 7. So what we really have is 49 over 14, right? So let me rewrite this. We have 49 over 14 minus 7. And 49 over 14, if you do that with the calculator, it will give you a 3.5. You're going to be subtracting 7 from it, which gives you the final output of negative 3.5. So this is the y value of your vertex, okay? So when we look at this parabola, again, so she dives in, she pops back up. This minimum value is negative 3.5. So yeah, it took 7 feet. That was the x value to get here, but she's actually down deep, 3.5 feet deep, okay? All right, so that was just several problems for you to relate quadratic functions to real world situations.